All right, I think we'll get going. We hit triple digits on attendees, so I think that's probably a good opportunity to get started. Good morning, everybody. Also, good afternoon and good evening for those joining us from other parts of the world. But welcome. My name is Paul Lefebvre. I am a business development executive here on the Canadian team at MBSI WAV. And I will also welcome all of our colleagues, customers, partners joining us from the US from our WAV family. To be honest, we do, like I mentioned, have representation in the audience from all over the world. And I thank everyone for taking the time to join us. Joining me today is Louis Lambert, who is Chief Revenue Officer at Six Harmonics. I've known Louis for many years now, and I'm thrilled that he is bringing his knowledge and experience in the market to us all here today to take a little bit of a deeper dive into UHF Broadband, which is more commonly known as TV Whitespace. We've got somewhat of a what I would call a summary of the topics that we had questions on. So we're going to treat this as somewhat of a loose agenda, but ultimately the goal over the next 45 minutes to an hour here is to cover off many of these topics as possible. On a daily basis, we continue to see demand, for connectivity. It's part of our lives. Our industry is absolutely filled with a number of great manufacturers, all of which have great solutions, each with their own, uniqueness to the market and the applications they serve. And no difference here. As you can see, from our audience mix, some of the pre-questions that we had come in, from our service provider and operator customers globally, we had common requests for rural coverage growth, distance, throughput, particularly on network designing, and still have people answering the question. But hopefully we'll have the time to cover all of these. From the industrial market, our system integrator, our partners, we see many requests that came in for rural coverage, distance, applications related to SCADA, industrial IoT, and we absolutely did receive a number of requests and a number of questions on how TV Whitespace and UHF Broadband correlates with the 900 megahertz space, and some of the options related to the deep install base that 900 megahertz has globally. And we'll be covering some of that material during the webinar. And then finally, from the government perspective, city officials, state officials, we did see a number of requests around community-based private networks. It's a very interesting use case study using TV Whitespace for that. And then other aspects such as regulatory compliance, spectrum funding. So these types of use cases do exist today, and Louis will be touching on them as we move through. But of course, it doesn't have to stop there. As we move through the session, if anyone does have any questions or want something that they would like answered, feel free to use the chat window at the bottom of your screen and type your question in there. We'll sort of be collecting them as we go along, and we've got some time set aside at the end to answer them. And in addition to that, we want to make sure that people are paying attention. And as we mentioned when we started promoting this webinar, there's going to be an opportunity towards the end for one of our audience members to win a $100 Amazon gift card, which I guess is just in time for Christmas. The TV Whitespace UHF bands, they've been around the market for many years. And I think it's safe to say that, there's been a number of manufacturers that have taken a crack at this space. And we recognize, that there are apprehensions around these types of solutions, but ultimately the goal here today is to dispel some of these myths and educate the audience on some of the exciting possibilities with the technology. Louis, this might be a good time for you to step in.
Sure.
A bit of history on the space and how Six Harmonics is viewing this market. So thank you, Louis. I'll let you go from here. Yeah.
Thank you very much. Everybody, thank you. I'm not gonna go through the same introduction as Paul did, but thank you for MBSI. You guys are a great partner. They're a strategic partner of ours, and a great bunch of people. And again, all of you folks that have decided to put some time aside to find out how we can help you with robust UHF broadband connectivity. So we're going to cover the topics that Paul mentioned, and we have also let one slide to give you a teaser of some of the other things that we do besides TV Whitespace. So every presentation needs to have a disclaimer. We are going to be talking about looking forward, with product availability and all of this. So everything is based on our best estimate as today, right? So it's an important, just in case there's some lawyers in the room. So 6 harmonics and TV Whitespace then and now. So I think Paul said it really well. There was originally some apprehension. TV Whitespace and the database of TV Whitespace was precursor to CBRS. And it certainly did not have the marketing engine that Microsoft and the rest of the world had with CBRS. So people used to be scared of database. People now are embracing database. Regulators used to be scared of them, and regulators around the world are embracing that in a way to monetize their spectrum. But for us end users and manufacturers, it's an opportunity to make sure the spectrum doesn't get too convoluted and unusable. And a main topic of today on the agenda. So 6 harmonics come from the TV Whitespace, and we're continuing to evolve our TV Whitespace. Our mission and our vision is basically to try to make it simple. We want to make it simple for people to deploy critical service at the edge, whatever it's a digital divide service, or it's a remote PLC, or it's a hauler or something, right? We also, from a mission perspective, we're building hardware and software. And we are trying to enable people to be able to do real-time decision-making or real-time education or real-time surgery, right? So it's really important for us that if we make it simple, more people adopt it and they deploy it. Paul, if you could switch. So the company is, well, I've covered some of this, but a couple of important points here. At the end of 2021, the board of directors and the investors made some change, brought a new CEO. The new CEO brought a new team and re-energized the company with more money, more people, a different group of people. And in the first 6 months, we basically established what is it we want to do with this company besides TV Whitespace, and how do we want to grow TV Whitespace. So the result of what you're seeing today was initiated at the end of 2021. And there was an awful lot of work done. And it went from 7 people to 25 people. And the result is what you're about to see. You can go to the next slide, Paul. So just to give you a perspective as to why TV Whitespace is important, or UHF Broadband, there is an awful lot of money spent outside of the industrial space, just in digital divide. This is just digital divide. And they can't do it all with fiber and 5.8 and CBRS. There's always going to be an area that in digital divide they can't do with the high volume bands. They're going to have to go to UHF. And there's not that many choice in UHF. This is the choice. You want to move to the next one, please? So this is not only for the digital divide. The early days of TV Whitespace was only for digital divide. But what has happened is the industrial markets, oil and gas, mining, water, wastewater, they're all trying to do what some call SCADA 2.0, right? Or IoT, or, IoT or IIoT, Industry 4.0. The fact is they want people and device to be connected all over the place. And this all over the place is not always in reach of 5.8. So as an example, you can look at a number of places around the world where we've helped, in the digital divide One of our most recent announcement was Pictou County in Nova Scotia. They're going to have 600 TV white space remote device out there. They're all 6 harmonics. And the reason why they have to do this is that it would have cost them way too much to put towers to reach everybody with 5.8. So the cost of the radio was a lot less expensive than building more towers. In the industrial space, we made public that Shell was using us offshore because they were connecting vessel with 5.8, but as they get past the 5.8 range, they were losing completely. With our equipment, they tripled the range of 5.8. You can go to the next one, Paul. So we'll talk about distance and throughput, but let me maybe switch to the next slide and just show you a bit of a visual. We're going to show you a few visual slides where we're talking about 1 kilometer, 1 mile to 30 kilometer, 18, 20 miles. It's not a technology that will give you gigabit per second at 1 mile, but it's a technology that will give you more megabit per second than any other technology at the other end. And it's not just because we have great radios, it's also the band. The band is really allowing us to do a lot more than just a little bit of communication in the best of time. We do have the same non-line of sight as 900. As a matter of fact, we have better non-line of sight. We're lower on the spectrum. And the cost of ownership is comparable to 900 because it's all about the towers, right? You want to go to the next slide, Paul? So we do have a bit of a global audience, but even if we were talking to specifically Canada and US people, I would still like to show this slide because the ecosystem benefits from a global distribution power. Manufacturers cannot lower their price if they don't have volume, and you cannot have volume if you don't have access to the globe. So this slide is very important for you to understand, even if you're a US or Canadian person in the audience. The rest of the world help you lower the price. So I just wanted to give you an idea of which countries around the world is doing this TV white space now. And I could tell you that when I started in TV white space 20 years ago or 15 years ago at Redline, there was 2 countries. So you want to go to the next slide, Paul? So we're going to spend a minute or a minute or two on this. Oh, I think you went too fast.
Oh, too quick.
Yeah, fast mouse.
It is.
So let me explain to you this what I was trying to convey with this. On the vertical axis, you've got the location on the tower where you would put equipment. On the horizontal axis, you basically have range or distance, right? So in the size of the marker used is in the thickness of the line, is the megabit per second that band can actually deliver, regardless of the manufacturer, right? So we're seeing a huge amount of movement in 5 gig, in 6 gig, and even still in 2.4, because they have wider channel and they can reach people at a real good, reasonable range with big capacity. UHF does not have big channel. So if you don't have big channel, you can't have big capacity. But UHF gets you that channel much further down the road. And there's 2 noticeable UHF band around the world. The 900 ISM or the 900 private, we're going to talk about the ISM one now, and the TV white space band. They have very similar properties. The only difference is there are gazillions of people using 900 ISM. And I can tell you with confidence, because we're close to the database managers, there are less than 500 TV white space device installed in North America. The band is completely available. And I just mentioned earlier on that Pictou was going to deploy 600. That account alone will double the amount of TV white space device installed. So it's a gold rush. Anybody that is having problem with 900 megahertz today and still wants to be in UHF, should seriously look at this. Go to the next slide, Paul. So if you are a 900 megahertz customer today, and you have an ISM 900, you're not getting the throughput you wanted to get. You're not getting the distance you wanted to get because you're fighting interference. You have a couple of choice, right? Do I go up spectrum, like on the previous slide, and then you lose range, so you need to build more towers? Or do I stay in UHF? And if I stay in UHF, what are my choices? And the real choice is really broadband UHF, and there's no real other choice. So go to the next slide, please, Paul. So this slide helps paint the picture differently. On the left side, you have 700 megahertz TV white space, you have 600 megahertz, you have 900 megahertz, and they're all small towers and tiny little antennas at the remote end at 20 miles away, right? And then if you go in 2.4, 5.8, 6 gig, big towers, big money, lots of them. And at the remote end, often if there's trees, you have to be above the trees. So the infrastructure cost of 900 ISM was the driver for the success, because the infrastructure cost is far less, right? So if you're a 900 megahertz user today in the ISM band and it's unusable or not reliable anymore, the logical choice is to stay in UHF, so you don't need to start to be in the tower building business. And the tower building business is the total cost of ownership. The equipment price is irrelevant almost when you start looking at doubling, tripling the number of towers. Excuse me. Next slide.
I think, yeah, no, I just, I'm going to just jump in here real quickly.
Yeah, go ahead.
You know, I'm not going to circle back to the previous slide, but I think you were making an interesting point and analogy. And, you know, from our perspective as MBSI WAV and WAV, you know, we've got a number of different relationships with a number of different manufacturers, like I mentioned earlier, all with their own sort of, you know, unique product line and, you know, view of the market. And, you know, you touched on it, you know, as you go up in frequency range, you know, you're typically blessed with extremely wide channels, and that's where we see, you know, a lot of solutions in dense areas, community-based networks, you know, using, you know, gigabit style radios for coverage. And then, like you mentioned, as you get into, you know, a little bit longer distances, you're getting into 2.4 and 5.8. And I think you're making a great point here of, you know, extremely rural areas or private network scenarios, using UHF as an option to that. And I guess, you know, where I'm trying to frame this a little bit is in the actual use of the spectrum. I think it's an important aspect that we're actually using a model that's, I'd call it shared spectrum, or something that's, you know, regulated by, you know, some type of government entity, whether it being ISED or the FCC or other type of global organizations. And, you know, I look at that in the, you know, the license, it's not licensed spectrum, but it's a controlled spectrum. And for one aspect and one way to look at it is it kind of creates an asset-based solution for the operator, for the end user, where, you know, they're not only deploying a technology, but they're deploying it in a spectrum range that to some degree is regulated. And it sort of de-risks, you know, that aspect of it to some degree.
Yeah.
So, you know, I wanted to just, you know, add that. And I know, you know, the next section of this is sort of getting into that spectrum database management, but not sure if, you know, you have any comments on that.
Yeah, and somebody asked a question while we were talking to elaborate on the amount of channels. So there's 228 megahertz of spectrum, pretty much in every country for this TV white space. The UHF TV channel in most countries around the world are 6 megahertz wide. There's a few exceptions where it's 8, but most of the world is 6, and that's the worst case. So if you take 228 and you divide by 6, you have an idea of how many channels are available out there. And the number of UHF TV broadcaster has not increased with digital TV. It's reduced. So there's even more channel available now than they were last year, and there's definitely a whole lot more than they were, you know, a decade ago. So there's a ton of channel. I would say that they are where we need them to be. You don't need a lot of channel in New York City because you have fiber in New York City, right? But you don't need a lot of TV white space available channel in New York City. But if you go in for the Canadians here, anything, the whole population is pretty much 100 miles north of the border. You go 300 miles north of the border or 200 miles, there's not even broadcasting. Not a whole lot. So there's an awful lot of channel available. Same with New York, with the States. If you get out of the major city and if you get out of these suburban environment, you know, the rule of thumb is if the 4G coverage is not really good, it's a great place for TV white space. So that's a real quick analogy.
Absolutely.
I think we're ready to go to the next one. So we want to talk about a bit of design and how do you approach these, which is in line with that, how much spectrum is there. So we got these like 6 steps that we like to use, right? So step number 1 is we basically, when we're having a conversation with somebody that is inquiring, we want to know where they are. So GPS coordinate, AGL, and we have the capability to see how many channels are available at that specific location. So that's the first qualifier, right? How much channel is available? Can you get a good business out of this? If you're an oil company, can you connect your PLCs and your well pads, right? So how many channels? The second step is we'll do a small RF prediction of what could be done with these channels from your tower, your existing tower. If you want to build a new one, that's one thing, but we're trying to make sure that people don't have to build new ones. The third step is we'll give you a rough order of magnitude of, you know, how much work is going to be to do that and how much money is it going to be. Then if you like this, people order the equipment. And one of the things that we do that has not been done in TV white space before, or and a lot of broadband companies don't do it, is that we will preset the equipment and set the database. And the next slide will go a bit more in detail, so I'll talk about it on the next slide. And lastly, but not least, we want the 6 Harmonics customers to not have to worry about the database. So let's go to the next slide because I'm going to cover the database item. So earlier this week, we made an announcement. Announcement don't come just at the spur of the moment. Here's the rationale behind that announcement. In order for us to be successful in driving the price down, we need volume. In order to get volume, we need more than Canada and US. We need to go globally with TV white space. And you saw that there's a lot of countries around the world that allow it. So we're trying to remove all the little speed bumps and difficulties. And one of them is some countries don't have a database. Some countries do, and they don't know how to operate it. And a lot of times the database supplier is, if you don't pay your bill, they shut you down, right? So here's what we announced. We decide to work with Red. We work with all database, but we have a specific relationship with them where we're going to wholesale their database. And we're going to work with them and include the database in the entire process. So you buy a network from us, if it's within the Red database area, the radios are pre-arranged, pre-configured, and we pay the fee. And you don't need to worry, my accounting person need to make sure they don't forget to pay for the database management fee, right? Because if the FCC, if you buy a license from the FCC for licensed microwave, you pay it once a year, you pay it 3 years ahead if you want. You don't forget it. And you have somebody to do that. But in this shared spectrum world, you may not have anybody dedicated to do that. And what if somebody forgets to pay the bill? So we take care of all of it. We are committed to work with them and implement our solution with their database in additional countries, raising the volume, dropping the price. Go to the next slide. So we're working with a database. We're trying to make it simpler, and we're trying to do a bunch of stuff. but we also need to do another thing. We need to improve the technology. And in order to make it better, we are releasing today. We were not planning to release today. We were planning to do that in January. But when we saw many people were signed up, we decided to let the cat out of the bag today. So we're announcing today the introduction of our 5500 radio. The 5000 was the current radio. It was 5th generation. So this is 5th generation with a series of improvement. This 5500 radio is going through certification right now for Industry Canada, FCC, and ETSI, which is most of the European country and most of the African country. So go to the next slide if you can. So what have we done to this radio? In order to go after the 900 market, in order to go after more than wireless ISPs, and in order to satisfy the industrial customers that are trying to exit 900 and looking for a place to go. So we've made more capacity at longer range. So at whatever you're at, 10 kilometer, 20 kilometer, 30 or 5, 10, 20 miles, you will be able to get more capacity at that range than you were able to go to do before. We've created a separate Ethernet port in order for our industrial customers to be able to have a dedicated management port. Sometimes even WISPs will have a third-party maintenance company that needs to be able to get access to the radio, and you don't want them to be coming in on the same port as the payload traffic. So the radios have 2 ports. One is dedicated for today into network management. There's nothing preventing us later to have a second Ethernet feed to it, because we're going to be approaching maximum Ethernet speed. New mechanical rapid sector reselection. Although we're not officially allowed to use mobility in the TV white space band, what we can do is fast nomadicity. And so we've deployed that offshore, onshore, and it's a new addition to the software. We've improved the GPS reception. We've improved security with we had ADS security before, but AES was a bit taxing on the throughput. Now we have AES without tax. From a physical security, the second port obviously is a huge physical security. And the other thing that we're doing with the software is that we used to have different loads of software for different countries. So if you're an oil and gas company and you use us in Asia Pacific and you want to use us in Africa, you might have 2 different loads. So with the 5500, our global customers can deploy this anywhere, and it's always the same load of software. They all get upgraded at the same time. It's easier for their management. Go to the next slide, please. So it's a bit more of a plug and play solution than it ever was. It's actually a lot more plug and play. The bottom image there is a CPE with a little stubby antenna. Of course, you can unscrew it and put a regular GPS antenna with like a 3-foot cable. But from a CPE perspective, the stubby makes it much easier. It's a cleaner installation. It'll fit somewhere where the other ones would be more complicated. There's new mechanical. The CPE is completely new. The mechanical is completely new. The base station has been modified quite a bit. We've put a handle on the base station. That was at the request of the riggers, right? So they can hoist it up the tower. We made it simple enough that we have WISP that are using students to install CPEs. They don't know anything about wireless. They only need to teach them how to do weatherproofing and proper grounding. That's all they need to teach them. In the industrial space, we've got oil and gas customers that are using the on-site electrical contractor to do the installation because it's simple. Now, if some of you on the phone are reseller or VARs that are catering to the oil and gas industry, that would be you, because if you're certified to go on their location, they would be using you. So we made it simpler for you, and it's much safer as well. So we've done better mechanical, better throughput, balanced link budget. So MIMO, 2x2 MIMO both sides. So it's a balanced link budget. It comes, the CP will come connectorized or with a 30 centimeter, 12-inch flat panel, or a 60 centimeter, 2 feet flat panel. So we've done all these things. So what's next? Well, if we really want to motivate people, the next thing is, how much does it cost? So go to the next slide. So we're happy to report that we have broken the $500 mark. That has been a problem in TV white space. That has been a big problem. It's one thing to have a $500 cost. It's another thing to be able to sell it at $500. So we're launching this 5500 that will become available in February with all the certification, and also compatible with all the database around the world that are doing TV white space right now. And what we're doing is we're basically subsidizing the CPE. So I'm being completely transparent with everybody, because some of you guys on the phone are actually my old oil and gas friends, and I got a bunch of people here that have registered. So what we're doing is, because the channel size are so small in TV white space, you would not deploy like 50 of them on a sector like you could do in 5.8 or in 6 gig. The channel size are too small. If you divide, these small channel size into 20, 30 people, they won't get anything. Our average customers have between 3 and 6 CPE globally, and it's driven because of the size of the channel. So what we're doing is buy a sector at the $69.95, and we'll let you buy up to 10 CPE at $500. You're probably not going to install 10, but you may want to buy a couple of spares if on your first kit. And the reason why I'm saying you're probably not going to install 10 is just because, again, the small channel. Even if you can bond 4 channel and you have 4 channel available, that's 24 megahertz. You're going to get about, 60, 70 megabit per second. If you're in that area and you can get 4 channel, you're probably going to have a better return on investment as an operator to sell a 25.5 or a 40.10 service than selling small service. So you get a better ROI and a lower total cost of ownership if you keep your CPE count down. That's why we limit it to 10. And if you're an oil and gas or a SCADA operator, you no longer want SCADA 1.0, you want SCADA 2.0, you want cameras, some of them PTZs. So you're going to want 5 meg at every site anyway. So that's the deal right now. If you call your MBSI person and you say, I was on a webinar, I want to get some of these 5500, they won't have all the order code today because we rushed the introduction. We were supposed to do that in a month, but next week they'll have all the information. They'll be able to respond to your question. And we also be able to book some appointment with any one of you guys if you want a one-on-one, because you're not feeling comfortable disclosing some of your questions with a bigger audience. So that's the TV white space thing. But I want to spend a minute to talk about something else that we're doing. Unless you have a question.
I was just going to jump in real quick again, Louis. Appreciate that. I guess, and it actually came in on the chat, and we've had a handful of questions so far. I'm going to save a few of them for the end. And again, to everyone on the call, if you have any questions, throw them in there. But looking at, I guess, your existing install base, existing customers, previous models, like the 5000 as an example.
Yeah.
From a upgrade path compatibility standpoint for the existing install base, does the 5500, is it backwards compatible?
That's a very good question. And you know what? This should have been a bullet on the slide. I take this stuff for granted. Of course, right? So if you've deployed 5000 base station and 5000 CPE, because that's what we were selling up until today, we still have some, but I don't think people are going to want them anymore. So you can have a 5000 CPE talking to a 5500 base station, but more importantly, you can put a 5500 CPE to an older 5000 base station. The 5000 was a receiver diversity CPE. It did not have 2x2 MIMO, but the base station did. So if you put a new CPE on an older installation, you will get the benefit of 2x2 MIMO on that link. If you were a point-to-point customer, you could replace, let's say one 5000 get hit by lightning, you can replace a 5000 with a 5500. It's 100% compatible. As a matter of fact, with this new release of software, all the 5000 and 5500 will run the same software. And the purpose for that is to make it simpler for our global customers.
Great, appreciate
That
that.
was a great question.
And a quick follow-up, and it's really tied to the point on the slide, and I think it's an important message to hammer home on the RED database fees. So you're showing $120
Yeah.
here, and
So,
I guess is
yeah,
that
go ahead.
old model versus what you're covering, or just a little bit of clarity on that? Yeah.
So RED communicated with, so there's been some movement in the database. RED, Phoenix, and CSIR did some movement in the world on database. Most of these people are also going after CBRS because it's a great market. So the bigger one, they go after CBRS as well, and they are getting even bigger. So RED announced that starting in January, rather than be $30-$40 per base station and nothing for the CPE, it'll be $10. I'm speaking for the Canadian, the US market. It'll be 10 and 10. 10 for the base station, 10 for the CPE. And in Canada, I think it'll be more like 15, right? Because of the exchange rate. The fact is that people are paying a whole lot more than that for CBRS. And they're happily paying for it because it protects them from interference problem, right? You get what you pay for. If you go completely unlicensed in 900, you basically hope when you go to bed that in the next morning when you wake up, the interference has not gone so bad that your network is down. This is the price to pay. It's not licensed spectrum, it's lightly licensed. And yes, there is a fee. But with that fee comes the benefit. So I'll tell you what a lot of the WISPs are doing. A lot of the WISPs are charging the database fee as part of their fee. They're telling the customer, hey, if you want to live downtown New York City, I don't need to worry about this. I got fiber, I got this, I got that, right? But if you, Mr. Customer, decide to go live 200 miles from the nearest town and you're having some difficulty, I have to use different equipment to service you. So for the last decade or so, many service providers have been charging the database fee to their customer. Just pass it through and saying, I have to use this spectrum to service you. I would encourage for you guys to think about this. The customers won't mind paying. They made the choice to go live really far. And that's only in countries where there's database. The countries that have no database, well, you have less security from an interference perspective, but it's still an underutilized spectrum. I hope that answers the question.
Yeah, and I guess just to hammer it home based on the recent press release, anyone that's looking to deploy a 6 harmonics TV white space solution, you guys are including that fee.
Yeah, we got your back.
Got your back.
Not only we're paying for it, but we're making sure it's getting paid, and you don't get a letter saying we haven't received your payment. 60 days from now we'll disconnect you, because that's their right? So we take care of it. But more importantly, I think is we want to expand that globally. So we ship more units and we get higher volume and we can lower the price.
Right.
So let's go to the next slide for 1 minute, because I don't want to distract too much from TV white space and UHF broadband. But 6 harmonics will never become $100 million company or $200 million company if we only do UHF broadband. And that's been one of the problems in TV white space. The manufacturers have struggled because the volume was not there, and it was difficult for them to grow the business and lower the price. One way to do it is to increase the volume, partner with RED, and go global. That's one way. That's a real good way to do it. Another way for us to have growth in our company is to go develop an additional market that is adjacent, right? So the unit in the blue in the middle is our next generation product. It's more than just a TV white space. We are going to have a new TV white space eventually, but we're developing an edge compute. So it's, again, IP67, 3 interface cards. So most people would put 4G or 5G, Wi-Fi, maybe TV white space, or maybe LoRa. And then it's got under the hood a lot of ARM-based computing. So the wireless ISP that are looking at providing more value at the edge of the network, TV, phone, security, alarm, rather than have a kludge box, they can put all of their bolt-on services on this platform and still have a TV white space board coming out, or a 4G, or a 5G, or let's say LoRa, if it's something like sensors for an industry. Our oil and gas customers are going to be looking at this and say, hey, I can run a remote PLC, a virtualized PLC. I can run virtualized camera server. I can run all of this on an LTE network, 4G network, and I can even have a LoRa gateway at the very end. So we're developing this technology, and we're developing the software piece to orchestrate all these Docker container software that we're going to be hosting that are not going to come from us. And the idea here is to, again, have an easy button for our customer. So what does it have to do with TV white space? One of the board can be a TV white space. And for the WISP on the phone, that would be your edge compute platform that you can bolt on the outside of the house. You don't even need to ask people to put it inside. So if you ever have to service it, you don't even need to get in the house. And you can have a Wi-Fi AP go right through the house, right? So it's a new category of device. It just doesn't exist today. We're the first one coming out with this. And it's at the request of our oil and gas, mining, water, wastewater, WISP customers. So that was a teaser for what's coming from 6 Harmonics.
Well, the market's definitely trending and asking for edge computing, edge devices. You know, we see it every day. You see the trends towards it. So it's encouraging to hear that you guys are adopting that and you know, running with that technology curve on it.
Yeah, I think, you know, because we have a mixed bag on the phone. The WISPs are looking for stickiness and bolt-on service, and the industrial operators are looking to reduce the number of box. And they don't want to have to put a stainless steel cabinet at every location. Imagine putting we can attach this to a D10 bulldozer for mining, and they don't need to have they don't need to put a cabinet to house a bunch of little computers. Everything is into one, right? So it's the future, folks. I mean, pipes are us, it's not good enough. You need to do more than pipes. So I guess in closing, from my part, you know, we have a very simple approach. We like to meet with the customers, understand what they're looking for, understand their challenge, see how we can solve them. We have a great commercial partner in MBSI for some of the geographies. It's all about what solution can I bring to you so we can be different from anybody else. And it's also about support and maintenance and have a live person responding when you have a problem. And the support and maintenance is what drove us to bundle the database, so we're fully responsible for the unit working or not working. So thank you very much. That was my last slide. I'll give it back to you, Paul.
Thank you, Louis. Great job. All right. So now we're gonna kind of get ready to close this out. We did receive a number of questions, so we'll get to those in about 30 seconds here. But as I mentioned, and as we promoted, we do have a prize to give away. And the format that we typically follow with this is I'm going to provide a question here verbally, and the first correct answer in the chat window will win that gift card. And it's as simple as that. So
get ready for your keyboard.
Yeah, get ready for your keyboard. In 3, 2, 1. Yeah, no. So, you know, with the release of the GWS 5500 in early 2024, effectively now, if you choose to deploy that solution, whether in an operator network or an industrial type application, we're looking for the answer of what should you expect to pay for the cost to register that equipment into the database. how much will you be looking to pay? Oh, we got lots of answers.
Wow. Oh, we got a winner.
And the answer is no charge. No charge. And the
You know,
first,
Ron Bird, you're not allowed to bid on this.
Seamus, I think that's
Seamus, you're not allowed. You're an employee. Well, you're gonna have to go back in time, but there was a few people that got it right.
okay. Seamus is an employee?
Yeah, he doesn't count.
No kidding. Okay, Ingo Aprakuma, you are the first one here that answered correctly at $0. So we appreciate that, Ingo. You'll be hearing from one of our team members on the marketing side following this to make arrangements to get you that, whether it's US, Canadian, we'll figure it out. But we appreciate everybody's responses on that. We got quite a few. And what we'll do now is we'll just move to the last slide here. And Louis, we do have a handful of questions. So
Yeah, go ahead.
so first is, I guess, on bandwidth and the relation of CP sector to 10 CPEs. If an operator or customer was to deploy a 1 to 10 ratio, what would they typically expect to see on a bandwidth perspective? And going one layer deeper, if someone wanted to do like 100 megabit, 25 megabit service, is that possible in this?
Okay, so let's go for the easy one first. It's roughly 5 bits per hertz of payload traffic, right? So let's say you're not 100% at the highest modulation. Let's assume it's 4, right? On average. At 5 bits per hertz, and if the government only allows us to bond 4 channel. So that's 24 meg of full spectrum. So we cannot reach with this technology 100 megabit guarantee, even if you're fairly close. It's not designed. That question is probably driven by a BEADS requirement. This is not a BEADS 120 technology, and it's not because the technology cannot do it. It's just the spectrum. There's so little spectrum. The channels are narrow. However, there's other fundings in the States that are 25.5 that can certainly do that, right? There's a lot of technology to do 120, and they're usually shorter range. The 25.5 funding in the States and in Canada, this technology does it in a heartbeat.
Awesome.
So now the second part of the question, what can you actually get, right? So let's do worst case, and then you quadruple for best case. Let's do worst case. You only have 1 channel, right? You've got a lot of sectors that you want to install. There's 4 channel available in your area or 8 channel, and you decide that you want a lot of clusters. So you're using only a 6 meg channel. In the 6 meg channel, you can deliver a good amount of bandwidth. One of our employees, not Shamus, but one of the other one, lives in California. He's paying $69 a month, and he's getting a 5 meg down, 1 meg up. $69 a month in California, not in Africa, and not in the developing market. And he's paying a pretty penny, $69 a month. That technology could do this in a heartbeat. The customer, the service provider in that area, they're using 5.8. If they were using TV white space, they could probably double and triple the capacity because they're at the far edge of the 5.8. So with a single channel, we can guarantee a 15 meg down and 5 meg up. With 2 channel, you can do twice that. With 3 channel, you can do 3 times. And 4 channel, you can do 4 times. So I like to tell people the reality of life is a 60 meg downlink and something like 15, 20 uplink is what we realistically can commit to, and with a straight face. And that's payload traffic, not to be confused with some other companies advertising 100 megabit per second, but it's not payload traffic. You don't make money on TCP, you make money on, the real payload. So it's not because the technology is not available in the world, it's just because they're narrow channels. Hopefully that answers the question.
Yeah, perfect. And the same person that actually asked that question had just, I guess, confirmation, is the system multi-directional or is it point to point? So I guess the answer is both.
Yeah, so another good bullet, right? Because we were going to do only 900 and we decided to do a whole lot more. So the radios are software defined, and you have to tell the radio, are you a CPE or a sector? The sector can only be a sector or a master or a slave from a point to point. The CPE can only be a CPE. But from a software perspective, is it the edge of a point to point, or is it the edge of a multi-point? It's all software definable. So you only keep one set of spares. You don't need to keep different spares.
Great answer. And what would on the round trip latency, what kind of
Yeah.
characteristics are you
So
seeing?
again, I come from a father that was a cop and kept on telling me the truth is painful at first, but it's always the best. So we can do sub 5 milliseconds latency, but these are good conditions. The reality of life is that not all of your CPEs are going to be at the highest modulation. They're not all going to be next to the base station. So the latency goes up a little bit as you go further. And I think that what we see out there on average is our customers are going anywhere between sub 5 to 20, 25 milliseconds latency throughout their network. And it really depends on how taxed the base station is and how far the remotes are and how far they all are. So, which I'll open a caveat on this. If you have a 5.8 network and you've got 20% of your remote that are at QPSK, lowest modulation, these remotes are dragging the performance down of your base station because your base station spends a lot of time talking at low speed to these faraway devices. This is where the mechanics of TV white space or UHF broadband come into play. If you were to remove these faraway device from your 5.8 system, your 5.8 system would go up and you'd be able to sell more capacity. And you replace these faraway locations with TV white space, which were designed for that. You'll get a better overall throughput for all your customers. And you can charge more because you'll be able to sell up capacity. In the industrial space is the same. If you're trying to put a PTZ camera on an oil pad that is 10 miles from the CPE, from the base station, you're going to tax that base station so much that everybody's going to suffer. Remove the outliers from 5.8, put them on UHF, and everybody wins.
Great. On the topic of channel bonding, can you bond 4 channels in Canada?
Yes. Canada, US, and a few other countries allow up to 4 channel bonding. We actually were on the phone with ISED yesterday because we're trying to make the rules a little bit more flexible. But yes, you can bond 4 channels. We have customers doing that. As a matter of fact, if you go 250, 300 miles north of the border, there's lots of channel.
Excellent. Do you ever see a situation with the government's allowing, I don't know, the government's allowing, I don't know if that's the right word for this, but can you see the radio hardware using wider channel widths with bonding, like maybe 32, 48 megahertz with a software upgrade?
Could it be done with software? Yes, because it's not hardware related, right? Because it's how many carriers you want to put on. The challenge is not can you put 6 or 8. The challenge is that the regulators are demanding that they are adjacent channel. So finding adjacent channel in quantities becomes harder. Now, there are some discussion with the regulators that we could do non-adjacent channel, but then they're going to want the filters, the RF filters, to be so tight that the price of the equipment would have to go up. So I don't know if that's a good idea. They have lots of good ideas. FCC and I said they have lots of good ideas on to make the band even more attractive, but most of their ideas means that I would have to double the cost of my radio, and that's not attractive to anyone.
Makes sense. All right, we're getting close to our time here, but I've got 3 more questions. I just want to cover quickly. I know we had that spectrum chart that showed all the different options. We had a little discussion around that. How do you see in some of the rural areas the application of satellite or LEO and how that plays with TV white space? Would you look at it as competitive, or is there a complementary element there?
Well, I'll use the word co-opetition, right? So if you're a wireless ISP trying to service rich cottagers around a big lake, and there's not a whole lot of trees, but they're really far, satellite's a good solution, right? If you're, we were at a conference in Kelowna not too long ago, and a guy was saying, oh, I've got lots of cottagers, they got lots of money, they don't care, but their trees are so big that they can't get satellite. They have to mount them on the roof of the cottage or on the top of a pine tree. So satellite does, you know, we have a tool, it serves a great purpose. It's a hammer, it's not a drill, right? The other guys have a drill, they don't have a hammer. I think they coexist. And I think that I look at, you know, like Elon's Starlink as a great way to get backhaul in the middle of nowhere, rather than use licensed microwave with 15 hops, right? So it's a great way to get backhaul. It's not necessarily the best way to connect every residence all the time. So we see ourselves being used as a multi-point distribution or fan out hub and spoke type technology. And the middle of the wheel is a satellite uplink. We see a lot of that.
Very similar question, but not satellite, but moving towards a very sensitive topic in Canada is the migration from 365 to 3800 to 3900 spectrum availability.
Yeah.
You see UHF applying against that space.
Yeah, so US people on the phone, please don't laugh, we may even hear you. But the Canadian regulator, in some infinite wisdom, has decided not to make 365 available like CBRS, and they're taking the band back, and only the MNOs were able to bid on it. So what does that leave the WISP with? And the industrial customers like oil and gas and mining is they have to relocate themselves eventually. So there's a number of options. I would go back to the statement I made earlier on. If you use a mix of 5.8 and the TV white space, you'll cover more than what you get with 365. So whenever it's really close, and if 5.8 is usable, use it. If 5.8 is not usable, you can use UHF. The problem is the channels are smaller than what you've been used to, right? So I would say it's a combination. You may even want to save towers and say, I'm going to radiate using UHF from the towers where I had 365, and I'm going to put 5.8, but I'm going to limit the amount of 5.8 because of interference. I'll use 5.8 if I have to, and I'll use TV white space to go cover everybody.
Great. All right, 2 more questions, Louis. First one is, I'll phrase this the way I know how. What's your comfort level on distance of a link, and what's your record right now in some of the deployments you've seen? What's a realistic number to leave the audience with on how far you should push these?
100-kilometer, everybody likes to say this, it's achievable. You have to be between 2 mountain tops, and it's not going to happen very often. And it's not the most reliable, right? You know, it would be surprising to most of you guys that we have a lot of customers that we're 1 kilometer. It's pine trees, there's lots of them, it's a campground, they can't cover with 5.8, with 2.4, with nothing works, and we do it. So that's the extreme on one end, like small range. On the opposite end of the spectrum, no pun intended, we've got oil and gas company using us offshore, right, 20 feet above the ocean, which is very difficult to do, and doing 30 kilometers. That's real. That's reliable, right? So, but the average customers is between 3 and 7 CPE, and the bandwidth when they cannot bond channel. The bandwidth is usually 10-15 megabit per second. When they can start bonding, and most of them bond too, then they're getting a 25.5 service, really reliable at 20 kilometers.
Very good. Very good. All right, we're gonna leave you one last question, and it's more of a summary again on everything related to the database management and the cost. I know that you guys are you have worked something out with Red, but I think we had someone join late. Can you just reiterate one more time what someone would, under normal conditions, expect what the cost would be to register with the database, and what you guys are doing to offset that?
So
I'll leave you with that, and that'll be it for you.
Yeah, so for anybody that is using 6 harmonics, in Canada, US, where Red operates, we will manage, operate, and pay for the fee. If you were not a 6 harmonics customer, you would pay in the States $10 per month per device, CPE or base station, and in Canada, I think it will be $15. And what you get with that is you get the assurance that people know you're using the band, and they won't be encouraged to go there, so they'll choose a different channel. And also it protects the incumbent, and the incumbent won't complain about you. So there's a real big advantage to use the database, and it's mandatory in Canada, US, and we take it. We'll take it.
Perfect. All right, thanks, Louis. We've gone a few minutes over here, so we're going to give everybody back their time. We understand, very valuable, and like I mentioned earlier, we appreciate everyone taking the time today to attend this. This webinar was recorded, and if you want to forward it on, view it again, you'll find it posted very shortly on our social media pages. This question slide here had a few key codes that you could have clicked that would have brought you directly to each of the individual websites of the organizations. But we all have active social media accounts: LinkedIn, Twitter, Facebook. Encourage everybody on the call to follow us, like us, have a look at our websites. Obviously we're here to answer any questions that you may have. Obviously encourage everybody on the call to get in touch with your WAV or MBSI WAV account manager if you require any additional information. Both organizations have a great team of engineers in place, so we can help with any pre-sales, post-sales support. Obviously in the RF world that we live and breathe in, network design, network planning is a sensitive topic, an important topic. We want to ensure that our team is looped in with the 6 harmonics team to make sure that any deployments that you might be looking at get designed properly.
And to your satisfaction. Yeah,
absolutely. We are here to help. As always, this is one of many webinars that we typically run. We do have others planned in the future. We'll be sure to keep everyone posted on those. And I'm just going to close by saying once again, thank you everyone for joining us. Louis, great job. Thank you for taking the time.
Thank you for hosting us.
Always
it's a pleasure.
Always a
Yeah,
pleasure.
it's a pleasure. And thank you to everybody to putting some time on your calendar to listen to another way to solve problems.
Awesome. All right. Thank you, everybody, and have a great day.
Thank you. Bye-bye. Be safe.